Hello, yes, and welcome back to our Objective 5 notes. We are ready for Objective 5 Part 2 now. Now, if you remember, Objective 5 is all about solving linear equations. We started by solving equations, and then we found one with no solution. And we talked about the different possibilities for having one solution, no solution, or infinite solutions. We talked about what those looks like. Remember, if we solve and we get x as a number, that's one solution. If we solve and we get an untrue statement with no variable, that means no solutions. And if we solve and we get a true statement with no variables, that's infinite solutions. And then we did some practice with those ideas. We made sure we were all good to go. And now I want to finalize that idea, kind of talk about it a little bit more, and then we'll get into some word problems. And that'll be what we do today. So identifiers for linear equations, and these are ways that you can look at in a linear equation and really identify right away if it's going to have one solution, no solution, or infinite solutions. Equations that have one solution will have different coefficients. When you simplify the equation, if the coefficients on either side of the equal sign are different, then that's going to be one solution. Now, equations that have no solutions will have the same coefficients, but they'll have a different constant. All right, that's when there's going to be no solution, because that coefficient, remember, represents slope. So they'll have same slope, but different constants. They'll be parallel lines, but they're not the same line. Now, equations that have infinite solutions, remember, are the same line. So that means they'll have the same coefficient and the same constant on both sides of the equal sign. So what I'd like you to do real quick is I wanted you to take a shot at this challenge. Now, there's all sorts of right answers for these, but I want you to go ahead and pause the video, try to write a linear equation with one solution, one with infinite solutions, and one with no solution. Go ahead and pause, and then we'll check in with you in a sec. All right, let's check it out here. So writing a linear equation with one solution, all we need is an equation with different coefficients. So for example, 4x plus 3 equals 2x minus 5. That would do it. Obviously yours could be different. That's what I meant when I said earlier there could be all sorts of different answers. An equation with infinite solutions, remember infinite means it's the same equation on both sides. So same coefficient and same constant. So we could have 2x minus 11 equals 2x minus 11. That would give us infinite solutions. And then write a linear equation with no solution. So remember, those were same coefficient but different constants. So maybe like 3x plus 7 equals 3x plus 1. And that would be our example there of no solution. If you're not sure whether or not you did that right, go ahead and raise your hand and I'd be happy to come around and check. Otherwise, we're going to go ahead and dive into these word problems and see if we can't knock these out. So looking at our word problems here, Allison was looking at her bank account the night before the T-Swift concert, of course. She bought 6 tickets, paid $25 for parking. She sees she paid $250 for the tickets and parking combined. Write an algebraic equation that can help Allison solve for how much she spent on each ticket, then solve the equation to find out how much a single ticket cost. Awesome. So let's define our variable first. We want to know the cost of a single ticket. So we'll say T equals ticket. All right. So building this equation, we can see she bought 6 tickets, so 6T. She also spent $25 for parking, so add 25 to her total cost. So there's all the money she spent, and we know that that total amount is $250. All right. So that's the algebraic equation that we can use. Now solving this, well, let's give it a shot. What would I do? I'd subtract 25 from both sides, minus 25. I'd get 6t equals 225. Now 225 divided by 6, I actually don't know that off the top of my head. Let's see if we can't just use a calculator. 225 divided by 6. Aha. I don't know if you saw that before it went away. But when we look at that, we get 37.5. So that means that each ticket was $37 and 50 cents. That's a pretty good price of a ticket for a Taylor Swift concert. Not bad at all, Allison. All right, let's try another. Number 2, Mr. Wisman is looking at the cost of renting 6 buses for an upcoming band trip. Ryder charges a fee of $150 per bus and then $2 per miles traveled. Greyhound charges a fee of $250 per bus and then $1 per mile traveled. After how many miles traveled would the cost of the two companies be equal? Okay, so there's a lot of information here we kind of got to break apart. First, we know that there's 6 buses. All right, now Ryder is $150 per bus, so that'd be $150 times 6 plus $2 per mile traveled. Now we don't know how many miles we're going to have, so let's make that our variable. X equals the number of miles traveled, 2x. All right, now Greyhound charges $250 per bus, so that would be $250, and we still need 6 buses, and then $1 per mile traveled. So plus x. Number of miles traveled will be $1 each. All right, now solving this, let's break it down a little bit. Let's go ahead and multiply this out. 150 times 6. Well, 150 times 2 is 300, and then 300 times 3 is 900. So this would be 900 plus 2x equals 250 times 6. Well, 250 times 2 is 500. 500 times 3 would be 1,500. Plus 1x there. All right, now remember when we're solving these, we're going to get our variable on the same side. So we can subtract x. So we'll have 900 plus x equals 1,500. Now we got to get the number on the other, so subtract 900, and we'll find that x equals 600. 600 what? Remember, we're measuring miles. So after how many miles would the cost of the two companies be equal? Right? That's why we put that equal sign there. 600 miles is when they would become equal. All right. If you have any questions, raise your hand. Otherwise, let's try one more together. Let's try number 3 together. Cassidy and Lisa are looking at making custom shoes to add to their collection. Cassidy can make 3 shoes per hour, and her collection already has 29 shoes. Lisa can make 9 shoes per hour. Her collection has 17. After how many hours will they have the same number of shoes? So this is another one where we want to know when they'll be equal, right? So we're going to put these expressions equal to each other. So we want to know how many hours. So let's say H is hours. That's going to be our variable here. Now Cassidy starts with 29 shoes, and then she makes 3 per hour, so plus 3h. And we want to know when that will equal Lisa's, who has 17 shoes to start with and makes 5 per hour, so that'd be plus 5h. All right, let's break this down a little bit. Let's start by subtracting 3h from both sides. So we'll have 29 equals 17 plus 5h minus 3h would give me 2h. Next, I need to subtract 17 from both sides. Subtract 17. I'm running out of space here, so I'm going to move this up here. 29 minus 17, that's 12. So 12 will equal 2h. To get h all by itself, I need to undo that multiplication, so I'll divide by 2. 12 divided by 2 is 6, so h equals 6. So after working for 6 hours, it looks like they will have the same number of shoes. Fantastic. Raise your hand if you have any questions. Otherwise, why don't you go ahead and try number 4. Why don't you try to help Steph find the best deal on a moving truck? Go ahead and pause the video, and then we'll check it together. All right, let's see how we did. So Steph's trying to find the best deal on a moving truck. U-Haul charges 70 flat fee and then 40 per hour. City Movers charges a $100 flat fee and then 35 per hour. After how many hours will the cost of the companies be the same? Steph plans on needing the truck for 9 hours. Which company would have the lowest cost? All right, so let's break this down here. Let's start. The question is hours, right? After how many hours? That tells us our variable is again going to be hours. So we'll say h equals hours. Now U-Haul, their expression is a $70 flat fee, which means you paid just that, and then $40 per hour, so 40h. And we want to know when that will equal the City Movers. Now, City Movers' expression is a $100 flat fee and then $35 per hour, right? $100 flat fee, $35 an hour. So, first question, when will they be the same? So let's set those equal to each other. So we'll have 70 plus 40H equals 100 plus 35H. Let's solve that. So I'm going to start by subtracting 35H from both sides so I can get my variables all on one side of the equation. So I'll have 70 plus 5H, right? 40 minus 35 is 5, equals 100. Then I'll subtract 70. I'll subtract 70. I'll have 5H equals 100 minus 70 is 30. All right, now I got to divide both of those by 5. Divide by 5, divide by 5. 30 divided by 5 is 6. So 6 hours to equal. So they'll equal each other in 6 hours. So that's the first part. Now, if Seth plans on needing the truck for 9 hours, which company would have the lowest cost? Okay, so that's different. So now what we need to do is with this 9 hours, we need to plug that in for H and see which one would be lowest. So U-Haul, I'm going to do over here 70 plus 40 times 9. This is for U-Haul. All right, so let's do that on a calculator. 70 plus 40 times 9. And what do we get when we do that? We get 430. Okay, well that's quite a bit for U-Haul. Now City Movers would be 100 plus 35 times 9. So let's try that one on a calculator. 100 plus 35 times 9. That one's 415. Oh, goodness, excuse me. That one is just $415. So, which one's cheaper for 9 hours? City Movers is cheaper. Awesome. Let me know if you have any questions on that one. Otherwise, we got one more problem to do. Why don't you go ahead and knock out number 5. Go ahead and pause the video, and then we'll check to see how we did together, all right? All right, let's go ahead and see how we did here. So looking at number 5, the tortoise and his friend the hare are going for a race. Classic. Tortoise can move at 2 miles per hour. The hare can run at 8 miles per hour. To be fair, the tortoise was given a 24-mile head start. How long will it take for the hare to catch up to the tortoise? All right, so again, we're looking for how long it will take. And it looks like we're measuring in hours, so let's make our variable hours. Okay, so the tortoise and his friend are going for a race. The tortoise can move at 2 miles per hour. So the tortoise here can move at 2 miles per hour, but he has a 24-mile head start. So let's go ahead and add 24 miles to his distance traveled here. Now, the hare can run at 8 miles per hour. Awesome. And we want to know how long it will take for the hare to catch up to the tortoise. All right, so let's set these equal to each other. So 2h plus 24 equals 8h. Subtract 2h from both sides. Subtract 2h from both sides. That will tell us 24 equals 8h minus 2h is 6h. We got to get h all by itself, so let's divide by 6. 24 divided by 6 is 4. So that means h 4 hours. It will take 4 hours to catch up. All right. Let me know how you did. Go ahead and raise your hand if you have any questions. Otherwise, get to work on those practice problems, and I will check in with you soon. And this is Mr. Carter signing off. I'll see you next time.